There is something glowing in the deepest images we have ever taken of the universe, and for 3 years nobody could tell you what it was. It wasn't a galaxy, even though it looked like one. It wasn't a star, even though it was shaped like one. It wasn't a black hole, even though it was eating like one. It was just a small, deep red point of light, and there were thousands of them, scattered across every direction astronomers pointed the telescope. We have a name for them now, the simplest possible name: little red dots. And the leading theory for what they actually are is so strange that it requires inventing an entirely new kind of object, a creature that has never appeared in our textbooks, our simulations, or our equations. This is the story of the black hole star. To understand why the little red dots are a problem, you need to understand how astronomers normally tell objects apart. They don't really see things, they read light. Every object in the universe, every star, every galaxy, every cloud of gas leaves a signature in the wavelengths it gives off. Hot things glow blue. Cool things glow red. Dense things absorb specific colors. Spinning things smear those colors. The pattern of light coming from an object is essentially its barcode. So when astronomers look at a galaxy, they expect to see a barcode that says, "This is made of millions of stars at various temperatures, with gas around them, drifting in a particular direction." When they look at a feeding black hole, they expect a different barcode entirely. Brutally hot disk, violent jets, X-rays leaking everywhere. The little red dots have a barcode that does not match either one. Parts of it look like a galaxy, parts of it look like a black hole, and parts of it look like something that should not exist at all. That is the puzzle. For most of 2023, astronomers thought they had it figured out. The dominant theory was that little red dots were just very dense early galaxies, tightly packed bundles of ancient stars, glowing red because their light had been stretched by the expansion of the universe. It was a tidy explanation. It fit the timing, it fit roughly the colors, it worked. Until people started doing the math on what density actually meant. To produce the brightness astronomers were seeing, a little red dot would have to cram more stars into its core than any galaxy in the known universe, by a wide margin. Stars would be packed so tightly they would physically collide with each other. The model didn't just stretch the rules, it snapped them. So a team at the Max Planck Institute for Astronomy, led by Anna de Graaf, designed a survey to crack it open. They called it RUBIES, Red Unknowns, Bright Infrared Extragalactic Survey. Between January and December of 2024, they used nearly 60 hours of JWST time to collect spectra. Not just images, but the full light barcode of 4,500 distant galaxies. Out of that haul, 35 of them turned out to be little red dots. Most had been seen before in images, but never had their light been read this carefully. And buried in the data was an object so extreme that the entire team stopped what they were doing. Its barcode had a feature called a Balmer break that was more than twice as steep as anything ever recorded. They named it the cliff. Here is what makes the cliff difficult to picture. The object outshines 250 billion suns. The entire Milky Way galaxy contains roughly that many stars in total, so this thing is putting out the light of an entire galaxy. Fine. We've seen things that bright before. The problem is the size. Take our solar system. From the Sun out to Neptune is about 4 light hours. The nearest star to us, Proxima Centauri, is just over 4 light years away. The cliff fits comfortably inside that gap, an entire galaxy's worth of light coming from a region you could fit between our Sun and its closest neighbor. The luminosity of 100 billion stars packed into the space of 0 stars, that should not be physically possible. The contradictions kept piling up the more astronomers looked. First, the cliff is too small to be a galaxy, but it has light patterns that look like millions of stars overlapping. Second, it is bright enough to be a feeding supermassive black hole, but it is not giving off the X-rays that every other feeding black hole gives off. Chandra, NASA's dedicated X-ray observatory, has been listening for those signals for over 25 years. From the cliff, there is nothing. Third, the absorption pattern in its spectrum matches the dense gas you'd expect to find in the atmosphere of a single, ordinary star. Not millions of stars overlapping. One star. Except a star the size of a solar system glowing as bright as a galaxy. Fourth, and strangest of all, little red dots only existed for a window of about 1 billion years in early cosmic history. They appeared, multiplied, and then almost completely vanished. Whatever they are, they were a phase. That last fact is the one that rewrites everything. In September of 2025, de Graaf and her colleague Rohan Naidu published the proposal that pulled the whole picture together. What if the little red dots are not galaxies? Not standard black holes, not stars, but a hybrid object that combines the worst of all three. Imagine a supermassive black hole feeding so violently on the gas around it that the gas itself never has time to fall in. It piles up. It forms a thick, hot, turbulent shell around the black hole, like an atmosphere wrapped around a planet. From the outside, that shell glows. It glows so brightly that it looks exactly like a single colossal star. From the outside, you can't see the black hole at all. You only see the surface of the cocoon. A black hole dressed up as a star. The theory was first proposed in 2006. Nobody thought we'd ever actually see one. Here is where it gets serious. For 2 decades, astronomers have been staring at one of the biggest unsolved problems in cosmology. Every large galaxy in the universe has a supermassive black hole at its center. Ours has one. Andromeda has one. They are unimaginably heavy, millions to billions of times the mass of our sun. And the question that has haunted the field is, how did they get so big so fast? There simply wasn't enough time in the early universe for ordinary black holes to grow that large through normal feeding. The math doesn't work. Something must have given them a head start. Black hole stars might be exactly that head start. Cosmic mass factories, gorging on gas behind a hot curtain, building up enormous black holes in a fraction of the time anyone thought was possible. If the theory holds, it solves one of the deepest puzzles in modern astronomy. And the cliff is not alone. Since JWST turned on in 2022, astronomers have been compiling a list of objects in the early universe that simply do not fit. Galaxies that look too mature. Black holes that look too massive. Now, an entirely new category of object that may not be either one. The pattern is getting harder to ignore. It would be easy to spin this as scientists being wrong. That's not quite right. The models we have aren't broken, they're incomplete. They were built before we had a telescope this powerful. They were our best guess given what we could see. Now we can see more, and the picture is filling in. That's not a crisis. That's the entire point of building better instruments. The universe is allowed to surprise us. In fact, that's the only reason any of this is worth doing. But if black hole stars are real, where did they come from in the first place? You can't just spawn a supermassive black hole out of nothing. Something had to seed them, and the leading idea for what that something might be is even stranger than the black hole stars themselves. In 2007, astrophysicist Catherine Fries proposed something that, at the time, sounded like science fiction. She suggested that the very first generation of stars in the universe may not have been powered by nuclear fusion at all. They may have been powered by dark matter. Dark matter is the substance we know is there but cannot see. It makes up about 6 times more of the universe than ordinary matter, and we still have no idea what it actually is. We know its gravity, we know its effects. That's all. Fries's idea is this. In the very early universe, dark matter clumped before ordinary matter did. Hydrogen and helium gas fell into those clumps. And if dark matter particles, when they collide, annihilate each other and release energy, then those gas clouds would have been heated from within, not by fusion in their cores, but by dark matter destroying itself everywhere inside them. The result would not be a star like our sun. It would be something far larger, far cooler on the surface, and far stranger. She called them dark stars. Here is why dark stars matter for the little red dots. A dark star in Fries's model can grow to 1 million times the mass of our sun. When its dark matter fuel finally runs out, it collapses, and what it leaves behind is not a normal black hole. It's a seed already weighing thousands or even millions of solar masses, ready to start gorging on gas from the moment it forms. In other words, dark stars could be the parents of black hole stars. And black hole stars could be the parents of supermassive black holes. A three-generation family tree that explains how the universe went from a smooth fog of hydrogen to a network of galaxies anchored by impossible monsters at their cores, all within a few 100 million years. In 2025, a team led by Cosmin Illy at Colgate University identified spectral signatures in JWST data that match exactly what Friis predicted dark stars should look like. The evidence is still preliminary, but it's there. None of this is settled. Black hole stars are still a hypothesis. Dark stars are still a hypothesis. The cliff might turn out to be something else entirely, something we haven't even thought of yet. JWST has more observations scheduled. Other telescopes are joining in. Over the next few years, this story will either solidify into a new chapter of cosmology, or it will collapse and send everyone back to the drawing board. Both outcomes are exciting. What we can say with certainty is that the universe just handed us a new kind of object. 3 years ago, it didn't have a name. Now it has a theory, a flagship example, and a candidate origin story. That's how fast our picture of reality is shifting right now. What do you think these things actually are? Real black hole stars or something we haven't figured out yet? Let me know in the comments, and don't forget to subscribe.